Hello everyone, my name is zhuo, and today I will demonstrate my project. My project name is the simulation of unattended wireless sensors network. Um, Unattended wireless sensors network UWSN is a network formed by a set of automatically sensors. These sensors cooperatively send data package to one terminal in this network, and the sensors is required to store data until they receive the same package with a path containing its ID. And the node is a basic element in this network, and they are a great member of node in the network connecting to each other, and the structure of this node become a network topologic. However, it is a great challenge for us to ensure the reliability and security when the sensors accumulate data and the broadcasting package, because all the accumulate data in one sensor would be completely lost if it crashed, and the attacker can easily get the data if he owns the key of the sensor. So we need a reliable and safe distribution scheme to avoid this accident. And in my project, I propose to simulate UNS network by three data distributed storage schemes to improve forward and backward security and reliability of the network based on MATLAB. And a comparison among the three schemes we made to demonstrate the superpole of this the last scheme. And the two issues, forward security and backward security, is the two main security problem of USWN. So firstly, in my project, I will create node and topological structure and set up parameters just like the time of literature and the time and the number of the node and transmission range and threshold probability and unbounded threshold probability and extract and sum. And secondly, I will use the three scheme to simulate the network. The first one is native scheme, and the network will decide whether the data is locally stored or distributed into qualified candidate node based on the threshold probability. The next one is the dynamic key scheme is proposed by one, and the final one is the best is the scheme proposed by Yiren. And finally, my creativity is I will compare the three schemes and based on reliability and forward and backward security, and make a conclusion that the last scheme is super than the other. So I will first make the node mode. It has input, it has the threshold probability and transmission range, and its output is set of neighbor code, neighbor node, and the members of neighbor nodes, and a set of quantified candidates and number of quantified candidates. So you can see my code here. It is just node code. It's a function. You can see the input, and the output. It is exactly realize what I have shown here. And the second part is a topological of network. So generally it's like this. It's a network, and let's assume there are n nodes in the network, and we can plot the graph here like this, and yn set of n represent the census nodes, and set e is represented as edge age. So it is node, it is edge, and then I will use for a three data storage scheme. As I say, this native scheme, it has a three step, and the advanced scheme is use the dynamic key. It has three step, and the enhanced scheme is RS code. It has five step, and then after I finish the three scheme, I will compare the SE and BSE and the reliability of them. So the whole scheme is just like this. The plot shows what I want to do in the code. And let me introduce the first scheme is native scheme. It has three steps. Step is first is initialize the system. So we know the mobile sync choose the secret key, and the edge of dot is security hash function. This key has initial value, and each census node I has one secret key like this. And then we in the next step is key generation, and we generate the key data in each round, and then we encryption it, and we use the key ki to encryption the original key, and once we have in the key data is encoded, and the security data can be protected. However, in this scheme, data would be reviewed in this scheme because mobile adversary owns key of ki of one census. When one census is compromising, as we know that the secret key is static and unchangeable, resulting that we cannot guarantee the FSE. Similarly, we cannot guarantee the backward security either. So we need to improve it. So we have the two scheme is advanced scheme. It's a dynamic key scheme. So so I will update the secret key in each round like this. And in this way, we can't get previously key from the mobile adversary when the sensor is compromised. Just like what happened in the naive scheme, the data when is encrypted, it will store in the census. Then the secret key is updated in the next round like this, and mobile sync can decode the key in this way. Since the mobile adversary cannot get the key in previous round anymore, the forward security can be satisfied. However, if a mobile adversary come back at round C and the data stored in one census from round B to round C can be decoded. In other words, the backward security cannot satisfied in this scheme, so we have the enhanced scheme. In this way, we want to divide the package of data into n shares, and there is 1 over m size of package data in each share using the RS code algorithm. And the original data can be recovered only if the census has received more than m data shares. In this way, physical attack can be avoided because only one census key is not enough to code the whole data. So there are 5 steps. The first is initialize of the system, just like the native scheme, and then it's data storage. And after census update, its key case, a plain text data is encrypted with the help of update key like this, and then it will share the data in this way. It's use the RS code algorithm, and then we will distribute data. And the census will choose a neighbors with the top secret degree, and then send one of the data shares to another, like this. And the whole data distribute can be represented like this. And the final step is data construction. When the mobile sync collect data from its neighbor, it will combine and recover them by the SR code. And let's see the code. It is already shown it is node code and it is top code. So in this code, we can build the top and the topological of the network. So we can define like how many nodes are there in the network, and like the range of the the network. So we can define everything in this code. And this is a simulation code. It's contained 3 scheme. And let's run the code. You see the result is running. And as we can see that you can see it's dynamically here. You can see it generates the node and show the distance and show the compromise probability and show that whether it's qualified or not. Because we have, yeah. Yeah, so it can show the result, and let me show how it's work. So there are 30 times literature to reduce the randomness, and the node member is 100, and the width and the length of those network is the 500 times 500, and the transmission range RT is 16, and the threshold probability is 0.3, and the upbound threshold probability is 0.001. And in our network, I will create a node with different compromise probability. You can see what's shown in my report. Here. Yes, here. So we generate nodes with random distributed risk of probability. So they are 20% nodes with 50% compromised probability, and 30% nodes with over 40 compromised probability, and 30% nodes with only 20 percentage of compromised probability, and the 20 nodes with 20 percentage of nodes with a 10 percentage compromised probability, and the threshold we set is must be over than the 30 percentage, so it can show the part of it. As we can see, my program can generate the whole as a UWSN, and each node on its unique ID represents one census, and one node has its neighbor node district and distance between two nodes. You can see the distance and the compromise probability of this node, and whether qualified to get one share of data and show the outcome. This is just a small part of the outcome, but because there's a 100 nodes in this network, and outcome will show the whole relationship of this network. And the whole outcome is shown here. You can see all of that. It's all the relationship shown here in this part. And then let me say about this picture. This picture is the the topic. This graph of the network is topological graph of this network. There are 4 types of nodes: red, blue, black, and green. Red node is node with half of 100 percentage compromise probability, and the blue node is the node. Yes, here. And the blue node is a node with 40 compromised probability, and the black node is node with 20 compromised probability, and the green node is node with 10 percentage compromised probability. So this graph shows the whole network. Each node represents a census. And here you can see the outcome of this, and I will explain it very carefully in the next part. So let's see the first graph. This is, the redundance factor is this, and the blue means the native scheme, and the red lines means the advanced scheme, and the yellow one means enhanced scheme. In this picture, we can see the native scheme has a higher probability of BSE to be compromised, which means that the native scheme has the least security level among the three, and the adventure scheme and enhanced scheme have low probability, which proves that the dynamic key scheme is much safer than static key scheme. And enhanced scheme is even more safer than the advanced scheme because it's lower than the advanced scheme. You can see the yellow line is lower than the red one. And picture 2, you can see here is naive scheme and enhanced scheme have relative higher data reliability, while advanced scheme has lower data reliability. It can prove that dynamic key scheme is less reliable than the static key scheme because the key will change, so it will become less reliable. But it's not too matter. And in the picture 3, you can see that when the number of neighbor node is increasing and the native scheme keep the same higher probability of BSE to be compromised, while the probability of BSE to be compromised of advanced scheme and enhanced scheme is decreasing a lot. The slope of enhanced scheme is higher than advanced schemes. It means that in the network containing relative few node enhanced scheme is safer than the advanced scheme. And these pictures say that when the random factor is less than 1, the result of the probability of BSE to be compromised is just as the same as picture 1, but the difference is the redundance factor is less than 1. So you can see the result is actually is the same with the result of picture 1. And the picture 5 shows that when the redundant factor is less than 1, and in other words, redundant factor is decreasing, data reliability of native scheme is decreasing. You can see here the red one is decreasing, while the data reliability of advanced scheme is increasing, and the data reliability of enhanced scheme is also increasing, which means redundant factor is negative correlation with data reliability of the dynamic key scheme. Enhanced scheme is still much more reliable than other scheme. So you can see that the blue one is enhanced scheme, and it's much reliable than other two scheme. And the last picture shows that when the redundant factor is increasing, the data of reliability of native scheme keep the same, while the data of reliability of the dynamic key scheme is decreasing a little bit, which can indicate the redundance factor is negative correlation with the data reliability of dynamic key scheme. And when the members of neighbors node is increasing, data reliability of enhanced scheme and the advanced scheme is increased when the redundance factor is 1. But if the redundance factor is less than 1, the data reliability of enhanced scheme and advanced scheme are decreasing, which means that we should avoid low the redundance factors, which is not safe for the system. However, when the redundance factor equal to 1, we can still get a satisfied result. So in all, as we can see from the six picture above, you can see the 6 picture. We reopen it, you can see here. We can see that no matter the redundant factor it is, an enhanced scheme has the best probability of BSE and FSE and the best data reliability among the three. And In my project, I simulate the unintended wire census network successfully and compare three schemes for distributed data storage. Um, the last scheme are dynamic key scheme, which owns much more safe security and reliability than native one, and the static key, which is the statistic key scheme. And among the of the three, the enhanced scheme has the best performance. That's my demonstration. Thank you.